Another notion out there that gets under my skin is that, we're all going to be drinking produced water, or we're going to farm with it. It's not the whole truth. I've been a water guy my whole career and worked, membranes and desal projects, et cetera. What you're really doing is you could actually crystallize this water with enough thermal energy, and it's gonna be expensive, but you could actually vaporize all the water. You can condense it, and then you end up with a huge pile of salt. You look at 20 million barrels a day in the Permian. If you were to turn that all into fresh water, I think it's an Empire State Building of salt every 2 days, to give you like a volumetric graphic in your mind. That's a much worse problem. A solids problem is a lot worse than a pumpable liquid that can be moved cheaply. As heavy as water is, it's a lot better to move it through a pipe and be able to inject it than it is to end up with a massive pile of salt that's not exactly our table salt that you and I put on a steak at night. So back to my thing about taking the model further with H2O, if you've maximized your reuse through connectivity, you've already minimized your disposal. You still are going to have that relief valve, but you're going to have the economy of scale to implement projects that can take it down further. My theory is you distill off water with thermal evaporation, such that you get to the point of, we'll call it salt dropout. So salt concentrations are really high in this water. You can take them to say 250,000 parts per million from the 100 or 150 they're at. But you can't go any further without seeing solid salt coming out. The water physically won't hold anymore. But if you do have an area of high utilization in an H2O type super system, what you can do is reduce your injection volume by, say, 25% right off the bat, and have a freshwater stream in that exact amount. You also then have still a liquid brine that is further concentrated, and to fund that thermal energy that it costs to make that freshwater, because the freshwater is not going to be worth the cost it is to make it, not in any time in our lifetime. I hope not, anyway, because that's a pretty dystopian future where water costs that much. But you've subsidized it a little bit with your water co-product. We call it a water refining. You then can further subsidize with different co-product streams on your newly condensed brine. So your parts per million of everything went from parts per million to parts per 750,000, right? You get 25% of the water out. And we know for a fact, in certain areas, we see valuable metals in the water. Everybody likes to talk about lithium, strontium, maybe even palladium in some areas. Well, if those concentrations are higher per barrel or per unit volume, your techno-economic feasibility of extracting them for profit improves. And so our whole thesis is, what the market needs in regions is, singularly controlled large regional systems that prioritize recycle and then leverage water refining to reduce disposal a little bit further. That sounds for us like a path, for a decades-long path to continue to develop oil and gas, and not do it in such a way that the water costs are immense and increasing, and also not in a way that we see seismicity and continued use of what we'll call near potable valuable water resources for completions.